Thank you so much, React Rally, for having me. It's a real pleasure. It's actually my first conference ever in the United States, so thank you so much for having me. Thank you. So, before I start, Stages already did some very good introduction to what the heck is going to happen here on stage, but I'm going to show you this AI-generated image, because there's a point to why this talk was created. You see, attending conferences can be overwhelming, it's exciting, you get to meet all these amazing people, you make new friends. But there are times that you hear these words that you understand, but do you really understand them in a sense? And what I mean by this is sometimes you have these topics, but you're missing the mental models behind them. What are mental models, you might be thinking? Well, picture sleeping. In your mind, you have all your mental model to all the actions of sleeping. And the same applies to these topics that we hear in conferences. We hear these words, but sometimes our mental models are quite not there yet. And I want to tell you something about myself that Tejas already said. I'm a huge comic book nerd. I have more comic books than I can read. I had to stop buying latest runs because it just kept piling and piling and piling. And one day I thought, what if I got my love for comic books, and I got these topics and words that I hear in conferences, but my mental models are not quite there yet. And I built a nerdy guide to some of these web trending concepts. So let me just reintroduce myself real quickly. Tejas already did an amazing job. I'm Daniel Afonso. I'm working as developer advocate at this company called OLX. I'm part of the DX team of Solid.js, and I'm an instructor at Hagget.io. Also, some other stuff about me. Recently, I've been releasing a newsletter on Substack on what's been happening on the world of Solid.js, so if you want to keep track on that, you can go check that newsletter. I also publish it on dev.to. Last December, I released an introduction to the React testing library on Hagget, and last year, I released a book called State Management with React Query, which is also one of my favorite libraries ever. And you can find me on X, LinkedIn, pretty much any social media at the handle Daniel JC Afonso. But enough talking about myself. Small disclaimer, there are going to be some characters on this talk that are from Marvel and DC Comics. I don't own these characters, so please don't sue me. And now you might be thinking, how will this talk work? Well, you're going to be making this talk. As I'm standing here right now, I only know one thing. I know I'm going to do a story on React Server Components because I've created it specially for this event for the first time. And the other topic, you're going to be picking it. So the way it's going to happen is, I'm going to show you 4 topics. One of them is React Server Components, which I already told you it's got to be picked. And from the other 3, you're going to pick one of them. So the way it's going to be picked is I'm going to tell the name of that topic, you're going to clap. The one that seems the loudest to me here on stage is going to be the one we're going to do. Then, for each of those topics, we're going to add 2 characters. One from Marvel, and one from DC. And you're going to vote once again. If you pick a character from Marvel, you're going to get a story, a comic book accurate story of a Marvel character who's going to teach you the mental models behind that topic. And this is going to be a comic book story, and at the end of the comic book story, oh, by the way, you clap if you want Marvel, you clap if you want DC. And I got ahead of myself. And then I tell you the story. And at the end of this story, what we're going to do is, well, we're going to go over the science behind it. Basically, we're going to go over what was the mental model I was trying to form while I was telling you that story. Okay? Are we ready?
Yeah.
Okay, thank you. So these are the 4 topics I bring you today. For the time constraints, we're going to see 2. One of them is React Server Components. So you can pick from either hydration, fine-grained reactivity, or resumability. So you know the drill. I'm going to say the name, and you're going to clap, make noise, do whatever you want to decide which of these topics we're going to go. So, who wants hydration? Okay, that was pretty good. Who wants fine-grained reactivity? Who wants resumability? Well, I might be biased, but I heard fine-grained reactivity the loudest here. So, for fine-grained reactivity, I bring you 2 characters. We have Watu the Watcher from Marvel, and we have Batman when he sat on the Mobius chair after the Darkseid War from DC. So, you know the drill. I'm going to say the name. You clap for the character you want. So, the Watchers. That dude was loud. Who wants Batman? It was this close, I gotta tell you. I've did this version of this talk a couple of times, and no one ever saw the Watu story yet on stage. But Batman won from me, so let's go with Batman. So, after sitting in the Mobius chair, and some context, the Mobius chair is this device created by the anti-monitors, which are like some godlike entities in DC Comics. And after sitting in the Mobius chair, Batman, in this case Bruce Wayne, could see it all. He could see all that has passed, all that is passing, and all that will be passed. Because this chair allowed him to check through time and dimensions. Now, Batman could see it all because of one thing, these time points. And time points and time derivations showed it all. Now, we might be thinking, what are time points, what are time derivations? Well, as the name might incline, time points are points in time where stuff happens, where we have certain events. Time derivations on the other side around is basically more expensive alternatives of the timelines, where you apply some changes to the time points and you get a derivation. So this might mean that the derivations depend on the time points. Now, Bruce knew he wouldn't change what happened because what's in the past is in the past, but the present and the future, who? That's a completely different thing. You see, every time something in these time points change, they tell him, they notify him. And because of this, Bruce made sure that nothing bad will ever happen again to people who he loves and people in this city and all around the world. So, for instance, let's picture that the rogues are attacking Central City. So these bad guys. What Batman will do is he'll send in the Flash, because Deed was just notified. So the Flash goes in, he saves the day, and he changes the time point. Now, because he changed the time point, the respective time derivation also changes. If, for instance, as Mr. Freeze is robbing Ace Chemicals, what Batman will do is, well, let's send in Robin and Red Hood. So they go ahead, they save the day, and they change the time point. If they change the time point, so does the time derivation change. Then next, if Metallo will in the future attack Daily Planet, let's just send in Superman as a prevention. So Superman goes there, he saves the day, changes the time point, and changes the respective time derivation. And, well, soon Batman was obsessed with saving even the ordinary crime, even before it happened. It got to the point where the GCPD, the Gotham City Police, had no more space for criminals. So they had to start to release some of them. This was a crazy, crazy run. But you see, this chair was made for gods. And Bruce was just a regular human. So all of this quickly took a toll on him. So if you want to know what happens in continuation to this story, this is actually adapted from the run from Justice League 2015 and continues on issue 42. So you can check it out. But this was fine-grained reactivity with the help of Batman. So before we jump into what fine-grained reactivity is, thank you for that. Before we jump into what fine-grained reactivity is, we gotta jump into what reactivity is. And reactivity, we can say that it's a programming pattern that lets you set a behavior that automatically reacts to data changes. Now, when you're talking about fine-grained reactivity, we're talking about a system that enables you to have a reactivity pattern built on top of this network of primitives, signals, effects, or derivations/memos. Now, these primitives will allow the framework to do something. First of all, frameworks who are fine-grained reactive, let's, for example, pick Solid.js, components only run once. There's no re-rendering, there's not anything. Components run once, and they use signals to basically tell the framework exactly when and where updates need to happen on the DOM. So there's no re-rendering, there's no need for VDOM. Signals enable this to happen. So this is solid code. It's JSX, so as React developers, we are very familiar with this. And signals, basically, in a very nutshell, are event emitters. They are event emitters who have getters, setters, and all the value. And this might sound quite boring. That's just state. Well, signals, when paired with effects, allow you to basically start having fun. Because effects are functions that will subscribe to these signals. And basically, every time a signal will change, it triggers this effect, and this effect is executed. So if you look at this code, we have two effects. One can be, it's more explicit because we're doing create effect. So this means that every time that count there changes, this effect runs. Now, then we have another implicit or render effect, we can call it, where we are attaching the count to the DOM on that paragraph. You see what's happening there is because that count is a signal, every time that signal updates, the framework knows that it needs to run an effect that will only re-render that count part. So it only updates that specific part. On the other side, we have memos. And memos are basically very similar to what we have in React as well, but they allow you to cache these derived values. You see, let's imagine we have a function called double num where we just want to multiply the value. This is a very, very low effort function, so it won't cause you performance problems, even if you call it a ton of times. But every time it's called, it's recalculated. So if we wrap it with something like create memo, it just basically runs it once, caches the value, and every time that function is called from that point on, it will return the same value, avoiding having to recompute. So now, let's recap with that definition under our belts. Let's recap how in the story we were trying to apply these concepts. So we started with time points, who were signals. And signals contain the point in time, which in this case was a value. On the other side, we had time derivations, which are memos. So they are derivations of the time points that we had. Here, we had an effect. So every time a time point changed, so every time the signal it was subscribing to changed, the effect ran. And then, what was happening whilst these actions were showing up, every time the signal changes, Batman gets notified and runs an effect that will update another time point. Because the time point updates, so the time derivations get recreated. And this was fine-grained reactivity in 8 minutes, I guess. Wow. So let's just do a very, very quick recap before we go to the next story. So fine-grained reactivity is a reactivity pattern built on top of these networks, signals, effects, and derivations. And real recap, signals, event emitters, have getters, have setters, or the value. Effects, functions that subscribe to these signals and runs every time they change, and the memos allow you to cache these derived values. And in a very nutshell, this is the basic mental model that you need to understand fine-grained reactivity. So, let's go back to our screen and take you to the story that I'm really excited to tell you as well right now, which is about React Server Components. Now, we had already seen React Server Components here. Tyler just did an amazing talk. Kent will still do an amazing talk today at the end of the day. Before we jump into it, I just want to do a disclaimer. The version of React Server Components that we're going to be seeing, there's no streaming. We're going to have, it's basically a system, React Server Components, where we're doing server-side rendering, and we have client components. So if you're already aware of how it works and you have a basic notion of the mental model, keep it in mind as we're going to the story. So here, we're going to have two characters. That person there was paying attention, thank you. So we have two characters, and let's see who they are. Huh? What's that? Excuse me, React Rally. Nobody cares about those guys, right? Huh. I see what's happening. Well, I guess our friend Deadpool is going to take the stage for this one. He just released a movie and he decided to make a cameo on React Rally as well. But okay, let's do this. Oh. Hello there, React Rally. You picked the right moment to join me. I just finished my lunch, chimichanga, and now because of plot convenience, I will do what you came here to see. And that is to build a sentinel. You know, the mutant hunting sentinels, right? They are very famous. They showed up in a bunch of movies. Now, I know what you're thinking. Hey, Deadpool, why a sentinel? Well, a certain doctor in Latveria wants me to invite to his premises certain mutants. I cannot tell you they are, but their names rhyme with Magneto and Biclops. I can also tell you, I'm getting paid big for this job, like real big. I'll be swimming in rivers of money afterwards. But either way, that doesn't matter. These dudes are stronger than me, so I thought, why not spend tons of money already and time to build something that specializes in dealing with mutants, therefore the Sentinels. So I tried to go on some DIY myself, but I just needed to borrow something from the MCU first. Hey, Jarvis! Mr. Wade, please return me to Tony immediately. Oh yeah, I will. Let's just finish the job first, and then we'll do it. So I borrowed this book from Tejas, and wait a second. Oh, okay, write book now. So I got this book for Jarvis and asked it to start building. But as you can see, not even Iron Man's bestie can seem to be working on it. I told you, Wade, it is too much information for this manufactory to handle. It took me weeks of hacking S.H.I.E.L.D. just to get all the protocols needed for getting this thing to work. And now you're telling me that this system that we have here doesn't seem to be able to build a Sentinel. Okay, I have to get creative. I'm going to borrow something from Doctor Strange, which is something that doesn't exist in the comics, but exists in the MCU, which is that ring in his hand. So if you watched the Marvel movies, you know where this is going. Luckily, I know exactly where the top secret S.H.I.E.L.D. manufactory for building Sentinels is. So, Jarvis, get in here and build me a Sentinel as soon as possible. So as Jarvis is uploading, Deadpool just goes like, okay, once it's ready, bring it to our manufactory. I need to find another issue with it, so Daniel has extra steps to explain this RSC thing properly. And now it's time for my favorite podcast. Contagious. Okay. So, as this is happening, plug to S.H.I.E.L.D., Jarvis has direct access to all the information needed to build a Sentinel. He also uses some throwaway tools to make the armor more steady. Deadpool note, that is exciting because those tools were super necessary for me once I got the Sentinel. Okay, thank you, Deadpool. So, after a while, now it seems like Deadpool is watching a live stream. He got bored of Contagious, or he finished the episode. Either way, after a while, the portal opens and the Sentinel shows up. Now, Sentinel plugged to the manufactory. Deadpool tries to have it work, and there seems to be an issue with it. Something is wrong. Hey, Jarvis, there are parts of it missing. It just says client component placeholder. Oh, pardon me, Wade. There are parts of it that require a different assembling mechanism. I have to rebuild these pieces here myself. Such plot convenient. So luckily, I know just exactly where in the S.H.I.E.L.D. manufactory to get the instructions to do so. So what Jarvis now proceeds to do is get these instructions from the S.H.I.E.L.D. manufactory and uses them to finish assembling the Sentinel armor. After a while, it seems like, it starts to move, and time to power it on. So there's a very cool GIF I did. Okay, so once the armor is finally ready and the Sentinel seems to be working, finally, it's time to go to work. And I guess that wraps up the story. My spidey sense is tingling. Oh. I guess Deadpool forgot he was a mutant in this version of the story. But, okay, this was React Server Components with the help of Deadpool. Thank you, Deadpool. Okay, so let's just recap and let's jump into React Server Components. So Tyler already did an amazing job. And before jumping into React Server Components, let's just talk about client components, because this is where the mental model got complex and got tricky for some people. In a nutshell, client components are still the same thing we had before. Basically, the mental model that we had before React Server Components, those are client components. Now, we started having some issues because these things, even if we did server-side rendering, they were getting shipped to the browser, getting shipped to the client. And, well, sometimes we had larger bundles. And these large bundles make the application slow. It has a lot of stuff to download. And, well, this is an issue. Another issue that we were having, we'd have to do a bunch of data fetching requests on the client, sometimes just to affect the initial render of our code. And this kind of would lead to stuff like client-server waterfalls. Now, server components show up to fix this issue. In a nutshell, and one of the best ways I've heard about explaining server components are, there are components that don't run on the client. Because the name is kind of misleading. They are server components, but they are not just server components. They can run outside of the server. In a nutshell, they can be what's called serialized components. And there's going to be a reason for that. Now, server components fix these issues we had before, because as Tyler already showed in his previous talk, you can fetch data directly on the server. So this means that while you're creating these components, you have access to the data source immediately there. You can fetch data. You can even do it, if you're in the same environment as your database, you can query your database directly through there. You do this, your page is rendered, the RSC payload is generated. I'll talk about that in a bit, and this stuff is sent to the client. Now, One pretty cool thing about RSCs is the bundles don't get affected, because unless you need some stuff that's being used on the client component, that stuff is not being shipped to the client. So if you have an app that's just runs on the server, just on the server when you're doing the server side when the generation of the RSC, then that part is used there and it's never shipped to the client. So let's recap in the story what happened and what we were trying to form, and then we'll go over the entire mental model of RSCs. So we started with a problem here. Deadpool had a problem because they were trying to build the Sentinel on the client side, and that stuff was too much for it. There was a very large client bundle, and it took him a lot of time to get that data. Now, once a client requests the page, what happens is, on the server, using React, the framework will generate this thing called the React Server Component Payload, and then uses it to generate HTML using server-side rendering. This is kind of what we're implying that was happening here. Now, we also implied a couple of things. Server components have access to the data on the source. There was no more need for Deadpool to hack Shield and fetch data on the client. If they have the data there, just use it. Also, another stuff, packaged used on the server are not sent to the client. That's basically what was happening here. So after a while, the client will get the page. But, not before, but the HTML is immediately showed because, remember, it was server-side rendered, so we have static HTML already. So this stuff is already shown. Now there's the but, because client components are only pre-rendered. That's what happens when we're doing server-side rendering. They are pre-rendered, so they still need to rerun on the clients as a process called iteration is happening. But in this case, yeah, they still need to render. So what happens here is, using the RSC payload, we know a couple of things, because the RSC payload includes the server component, but it doesn't include the client components. It includes just some information on where to download them from, and what props they might need. So after a while, what's happening is the trees are reconciled, client components are iterated, and we have our Sentinel. And well, this was server components in a nutshell with the help of Deadpool. So let's just recap the entire mental model that I was hoping to help build here. So once a browser requests a document, something happens first on the server side. The framework matches the request to the component that needs to be returned. The framework, using React, will render the server component, generating the RSC payload. Now, this RSC payload doesn't include client components, but as I already said, includes props and where to find them. The framework then uses the RSC payload to do server-side rendering and generate the HTML on the server. And the client components are also pre-rendered. Now, once the browser receives a response, the HTML is immediately shown because it was server-side rendered, so that part is done. But then what React will do is use the payload, which is on the virtual DOM, to reconcile the trees and update the DOM. Now, if client components are found during this process, the payload is used to download them and render them. And then they are iterated. And this was React Server Components in 12 minutes. Thank you so much. So to wrap up, because we don't have time for the other stories, but if you want to check them out after, please come see me. I'll gladly show them to you. What's the next topic? What's going to be the next nerdy guide to? Well, I would like you to stay tuned for the next talk. If you have ideas, please let me know. The server components one was something that I've been wanting to work on for a very long time, and I finally was able to do it for here. If you have ideas, if you have topics you'd like me to do a nerdy guide for, just let me know. Thank you so much. This was a really, really amazing event. I'm Afonso. Thank you.